Hello everyone, this is Jyoti Katigi from E&C department BGMIT Mudor. Today we're going to see the experiment on sampling theorem in the Skylab. Okay, we start with the basic instructions like clear, CLC and close. Okay, what these instructions will do, CLC will clear the command window, clear will clear all the variables which are there in the browser window. Then close will close all the figures those are previously there in the window. Okay, previously executed programs, if anything left like figures and variables, we want to clear those variables as well as figures. Therefore we are using, for every program starting, we are using these three instructions. Next is here fm is equal to input, enter the signal frequency. Okay, what is the signal frequency of the given input signal? That we need to enter through the keyboard, whichever frequency you want. Next, k is equal to input, enter the number of cycles of the signal. How many number of cycles if you want? If you want a sine wave, square wave, how many cycles you want on that signal? That you need to enter. Next, a is equal to input, enter the amplitude of the signal. Okay, the input signal amplitude, how much you want, that much you give to the through the keyboard. Okay, these are the input signals, input values you need to enter. Next is Tm is equal to 0, the time period. Okay, Tm is the time period you are taking. The initial value for this Tm is 0 we have taken in steps of 1 by, here this 1 by fm star fm, 1 by fm value, how much you'll take, here you are enter the input signal frequency, that fm value how much you'll take, depending on that it will calculate 1 divided by fm into fm. Okay, then the last value of the time is k divided by fm, where k is your number of cycles in the signal, fm is the input signal, k divided by fm. What this Tm indicates, the starting value of the time is along x-axis, the time will take, the starting value is 0 and the ending value is k divided by fm. How many steps you have to take? That is in steps of 1 divided by fm star fm. It will execute this. Suppose if you want to write here, for example, if I'll write 0 colon 1 colon 2, means like that, same as this. It with the starting value of the time axis is 0, ending value is 2 in steps of 1. That means you will get 3 samples, 0, 1 and 2. Ending value is 2. Similarly, it will calculate like this only. See, starting value is 0, ending value is k divided by fm, and the in steps of how many steps you have to take. One step indicates how much width. That is determined by 1 divided by fm star fm. Okay, that will indicates the time axis values. Next, x is equal to a star cos of 2 star percentage pi star fm star tm. That will generate the cos wave signal, cos of 2 pi fm this is. Okay, it will generate a cos wave with an amplitude of a. How much amplitude you are giving in input. Okay, it will generate, this expression will generate a cos wave with amplitude of a. Then we want to display this cos wave. That means we want to see the waveform of the cos wave. For that we need to write all this instruction if you want to generate any waveform. First I'll generate the waveform x. That is figure 1, first figure. A is equal to GCA of a bracket, that is close brackets. Here what it will do, it will take the x-axis values, whatever y-axis where it will start. X-axis value will start origin, similarly y-axis will start at origin. Next, plot in brackets tm comma x. Plot means it will continuously give the waveforms. Plot of Tm comma x. Tm is along x-axis values. Okay, whatever the division you are done here. Next, x is the cosine wave along y-axis. Therefore, it will plot the given cosine waveform. Then title will give title of that whatever the graph here. Title is the original signal I have given here. Any name you can give. X label, what is along x-axis. Y label, what is along y-axis. Okay. Next, x grid of 1. Each division it will show the with a dotted line grid. After executing, I will show how the grids will be looking. Okay, this part will display the given input cosine wave. Next is, we are doing the sampling theorem, means we need to check for the Nyquist rate. If the sampling frequency is less than 2 FM, the Nyquist rate is what? Nyquist Fs is equal to 2 FM. If the sampling frequency is less than 2 FM, if it is greater than 2 FM, if it is equal to 2 FM, that means undersampling, oversampling, all these things we have to consider. All the three conditions we have to consider. First, I will consider undersampling. Okay, before that, what I have written here, FNYQ is equal to 2 FM. Okay, Nyquist frequency, I have taken Nyquist rate, I have taken sampling rate, I have taken as 2 FM. Next, we'll do the undersampling. Undersampling means the Fs should be less than 2 FM now. Fs should be less than 2 FM. Therefore, what I have taken here, Fs is equal to 3 by 4 2 FM. That is FNYQ. FNYQ is nothing but 2 FM. Here I already initialize that. FNYQ is equal to 2 FM. Therefore, Fs is equal to 3 by 4 star FNYQ. That means we are doing the undersampling. Next is, for this, we need to display this waveform. If we are sampling, undersampling, if we are doing, we need to display that values. Therefore, for that, n is again n is along x-axis. N value are taken from 0 to k by fm in steps of 1 by fs. Next, for this frequency, what will be your xn? Fs, for this fs, what will be your fn? Xn is equal to a cos of 2 pi fm n. Okay, if you are changing the sampling frequency, for changed sampling frequency, you need to plot again the cosine waveform. Okay, this is about undersampling. Undersampling, you need to display that graph. Okay, therefore that figure 2 indicates its x-axis where it will start, y-axis where it will start, and it's a plot. Okay, along x-axis n is there, y-axis xn is there. Then we need to plot this plot of n comma xn comma r. Along x-axis n values will be varying, y-axis xn values will be varying. R here, R indicates the graph will be shown in the red color. Okay, the graph will be shown in the red color. That's why if you want different color, you can change the, instead of R, you can take it here green, blue, whatever color you want. Okay, so that we can differentiate the original signal with the undersampled signal. That's why I taken the different color. Next, give the title for this graph, X label, Y label. Okay, legend of sampled signal and reconstructed signal means sampled signal is represented by which color and reconstructed signal is represented by which color. It will be displayed in the graph. Okay, after executing, I will show how it will be displayed. Next, similarly for this also, we need to show the grids. That's why I written here X grid. Okay, this is for undersampling. This part is for undersampling. Next, Nyquist sampling. That means Fs is equal to 2 Fm. Now I will consider Fs is equal to, Nyquist sampling is Fs is equal to FNYQ. FNYQ previously I assigned as FNYQ is equal to 2 Fm. Therefore, now Fs value is equal to 2 Fm. For this value again we need to calculate the cosine wave, then we need to plot this graph. Same procedure, we have to take the time divisions, n is equal to, then you have to plot the signal x of n for this f of s, then you have to draw the graph using where the x-axis will start, y-axis will start, and the plot. Again also I have taken here red color for plot, then title, x label, y label, legend. Legend, it will indicate the color. Two colors of graph we are using. Red color indicates what, black color indicates what, it will be displayed in the graph. Similarly for here also you are using the grids. Next, last part is oversampling. That means what? Now fs should be greater than or equal to greater than 2fm. Now fs oversampling you are doing. Now fs should be greater than 2fm. Okay, therefore fs is equal to fn yq star 10. fn yq star 10. fn yq is 2fm. 2 into 10 is 20fm. Now fs value is greater than 2fm. For that oversampling we are doing. Therefore it is called oversampling. Next, for that n value will assign where the x-axis values will start, where it will end in steps of what. For this fs we are calculating. Then for the cosine wave will generate for this fs value. Then for the similarly for graph will generate for the oversampling. Figure 4 indicates oversampling. Okay, x label, y label, title, legend, x grid. All these things will be displayed. Okay, see, this is the explanation for part for the sampling theorem. Next, we'll execute this program. See here, triangle arc symbol is there. That is the execution part. You click on this. After clicking this, it is asking for whether you want to clear the console window. Console window is command window where you will type the expression and where you will enter the inputs to that. Okay, I'll click on yes. Now one more window is there. I'll open that window. See this part. This what it is asking. Enter the signal frequency. How much signal frequency you want to give. Input signal frequency. Suppose I'll enter now. The input signal as 100 Hertz. Okay. After entering 100, I'll click on enter button. Next, it will ask for enter the number of cycle of signal. How many number of cycles you want in a given waveform. I want 2 number of cycles. Therefore, I'll press 2 and I'll enter again the enter button. Next, it is asking for enter the amplitude of the signal. How much amplitude you want? I want amplitude of 2. Okay, I will type it as 2 and then I'll enter. Click on enter button. Okay, now it will show the graphs. One by one, I'll show the graphs. Okay, this is the first graph. Cosine wave we are generating because cos of 2 pi fm tm I have written. This is the cosine wave. See, cosine wave is starting at 0 because you have taken tm starting at 0 ending at k by fm. K by fm means it will come around 0.002, whatever the k value fm value you have chosen. According to that, it will show this end value and in steps. Whatever the steps you want. Here x-axis steps will be there. Grids means this dash dotted lines are shown along x-axis, along y-axis. These are nothing but a x grids. Okay, I have written in the program. It will generate a grids like this, x-axis and y-axis. Next, it will give the amplitude along x-axis. What is their amplitude? Along y-axis, y-axis amplitude, x-axis time, and this is the original signal. First input signal, this one. Okay, for 100 Hertz, this is the cycle. 100 hertz frequency cycle this one, and you are having two cycles in this. Up to here this is a one cycle. This is second part, second cycle. Okay, you want to generate two cycles, mean it will generate two cycles. If you want three cycles or four cycle, while entering only you have to type it 4, then it will show 4 cycles. This is the original signal. Okay, next part is next undersampled waveform. How we are getting undersampled waveform is this one. This is the undersampled when fs is less than 2 fm. Undersampling you are done. Fs is equal to 3 by 4 2 fm. Okay, for that it will generate a waveform like this. Because since fs is less than 2 fm, we are not getting the original signals. Fs value should be greater than or equal to 2 fm, then only the original signal will get. Since in this case this is the undersampled frequency, therefore we are not getting exactly what input is. Undersampling we are doing, therefore it will show up to here only. Here also starting value is 0, ending value is 0.02 in steps of. The first value you'll get here. Okay, this is the first one. The second one. 0, how much is the amplitude? It is starting amplitude at 0 is 2. Amplitude as 0.0067, it will be -1. Similarly, at amplitude at 0.0137 or 134, you'll get amplitude as -1, and at 0.02 the amplitude is again 2. Okay, then here it is displayed. This is called legend. Legend means black line. What it indicates? Here the black lines are there. Black line indicates the sampled signal. At this point we are sampled. Okay, this at 0, at 0.0067 and 0.0134 and at 0.02 we are getting 4 samples for given time period. Okay, black indicates the sampled signal, red indicates the reconstructed signal. Okay, we will get the reconstructed original signal when the Nyquist rate holds good. But here you are doing undersampling, therefore the Nyquist rate is not holding good, therefore you are not getting the exact original signal. This is the legend. Legend instruction we have used what the black color line indicates, what the red color line indicates in your graph. And here also we have shown with the grids. Next for Nyquist rate. Nyquist rate means when Fs is equal to Fm, 2 Fm. When Fs is equal to 2 Fm, how the graph will be? This is the graph. When Fs is equal to 2 Fm. Okay, for your Nyquist rate in the program I have explained, for that you'll get like this. In this case, the Fs is equal to 2 Fm. Okay, we are not getting exactly whatever the original signal is, but somewhat similar to the original signal. Okay, here also you have shown with the grids, and black color indicates the sampled signal, red color line indicates the reconstructed signal. How many samples you'll get? At 0, at 0.005, 0.01, then at 0.015 you'll get one sample, at the end 0.02 you'll get one more sample. Okay, this is about Nyquist sampling. Here heading is written. For each graph you need to write title, Y label and X label. This is about Nyquist sampling. The last one is that is oversampling. Whenever you are doing oversampling, when Fs is greater than 2 Fm, then in that case how the graph look like? The graph will be like this. Okay, this is the graph for oversampling. Here I have written the title, oversampling, when Fs is greater than 2 Fm. When sampling frequency is greater than 2 times the maximum frequency, then you will get a waveform like this. That means what you are doing, the number of samples we are increasing. If we are increasing the number of sampling rate, then you will get the original signal. It is like almost original signal. First signal what you got, it is same as that. Here, see here, the black lines sampled values are increased. black lines are increased. Okay, when we'll join all the tips of this black line sampled signals, you'll get a original signal or reconstructed signal. That means it is a original signal only. Okay, this is what sampling theorem, what original signal we are giving. If we are undersampling or if we are satisfying the Nyquist rate when Fs is equal to 2 Fm, when you are doing the oversampling, how will be the graph? That means if you want the original signal back whenever you are reconstructing, then the Nyquist rate should be satisfied. That is, Fs should be greater than or equal to 2 Fm. Okay, this is about this experiment sampling theorem. Thank you.